Hi there. This is a demo of the calculations for the Tipi project. In Math 20, you do at least 2 projects, probably 3. This is the one that you are required to do. It's not a particularly hard project, but there's a lot of calculations involved. So what I do is I go through a practice run using my numbers, and then you can do it yourself. All right, so you will need to start your project, the assignment sheet. You will need a handy dandy protractor, one of those things, and you need a ruler. If you need a protractor, make sure you get one from the classroom somewhere. You know where they are. Okay, so essentially, now bear with me, it's been a while since I've done this. Turn my camera. But you're not actually building this, but I built a scale model so that you can understand what I'm talking about, because otherwise it's just, there's a whole bunch of numbers and I don't know what to do. So the first thing we have to do is decide the dimensions of the Tipi. Okay, so 3 important things. How many poles you have? Now, mine has 6. Yours is not allowed to have 6. You got to use a different number. Okay, so first, obviously, right? The interior height, I'm not sure you can see it, but it is this bright orange string that's going up just like that. So it's from the floor, from the ground, all the way up to the top here. And we also need to know the diameter of the base. Now, remember, diameter is all the way across. And in the case of my example, I've got a diameter of 8 feet and an interior height of 10 feet. While we're looking at it, when we talk about the base frame of the triangle, that's this, right? From the center to 2 Tipi poles. And later on, well, this is, let me just turn my model. My model needs a little tape. Okay, when I start talking about the frame triangle, I'm talking about this stand-up triangle that fits here, and it's between 2 poles and across the bottom. All right, I'll refer back to the model when we get to the different parts, but let's get at our calculations. Yeah, 50-50 chance. Ooh, going the right way. All right, so ta-da. You make these decisions. You can't use the same numbers as me. Mostly, you can't use this one. Okay, you can make it whatever height you want and whatever diameter you want. If you have some experience and some knowledge, use some like real numbers. Okay, so first thing we're going to do is we're going to cheat a teeny bit, and instead of worrying about it being a circular base, we're going to make it into a polygon. Okay, so each pole is going to form a vertex or a corner, so the number of poles is the number of sides in your polygon. I guess I'm going to do this a lot. And if you look on the diagram, okay, so instead of having the green circle, what we're going to worry about is the polygon on the inside. And all I've done is connected from pole to pole to pole. I'm going to say, sorry guys, it's been a few months since I've done a video. There we go. Okay, so you take 360 and divide by the number of poles, and it tells you where to mark your vertices. So 360 divided by 60 is equal to 60 degrees. So every 60 degrees is going to be a new pole. Now, here. Okay, protractor. May have been a while for you. You're going to line that up. So see that part of the protractor right there, where you have the 90 degree and the 180. So that spot there goes right on the dot, and you're going to line it up with the line to the top. Okay. And then you're going to mark off 60. And I'm going to draw it through with my ruler. I realize that the way because there's an equal number of angles, equal number of TP poles there, that these lines are actually going to go all the way across. So the first thing I'm going to do is I'm going to do that. So that divides it in half. And I'm going to draw this line. And that's our first part. If you've chosen an odd number of TP poles, you can't draw all the way across. Now, so here is 60 degrees. Now I take my protractor and I use this line, the one I just drew, as my starting point. So I'm going to line everything up and see it's off there by a teeny bit with my drawing. And then I'm going to mark 60 degrees again. And I'm going to mark from that line. I'm going to go through my center. Just like that. So each one of these interior angles is 60 degrees. All right, so draw the line from the center to each of the vertices, connecting the vertices to make wedges. All right, we're also going to do that other part. So all you do is connect like that. So one. Again, if you're watching this, you probably could want to speed up through this part because it's not that exciting. But if you're doing it at the same time I'm doing it, you just pause yours and do your diagram. So I've got a six-sided figure, 60 angles, six sides matching the number of poles I have. So there'll be a pole here, and here, and here, and here, and here, and here. All right, there's our first page. Yeah, second page. Nope. Okay. So here's my example. Okay, and then you've got a drawing there. When I first did this, I hadn't planned to make a video to go with it, so I needed to add some stuff. Shade in one of your wedges. Okay, so we're back to page 1. You could probably do a better job than that. All right, check. Determine the length of each side. This will depend on the diameter of your teepee. All right, instead of flipping back and forth, I'm just going to use this. So I said my teepee is going to be 8 feet in diameter. So diameter, remember, is all the way across. So from here all the way to here is 8 feet. Now we want to know the length of each wedge. We want to know this. Wow, that's not too hard. If all the way across is 8 feet, then from our center out is going to be half of that. So you're going to have to go, I'm going to go 8 divided by 2 is 4. Not that complicated, right? We got this. So if this was 10 feet across, then this would be 5. If this was 16 feet across, it'd be 8. So it's just, you just divide it by 2. And that will give you the radius of your circle, right? Diameter is all the way across. So that's a diameter. And that's a radius from the center out. All right, since you know the top angle of the wedge and the 2 sides, you can calculate the length of the bottom. So you all know I'm a visual learner. All right, so this represents this, which is this, the base frame. So we know that this is 4 feet. By the way, that's shorthand for feet. That's 4 feet. And we know this angle, and we did it from here, 60 degrees. Well, that sure looks like an angle sandwich to me. Right, so we're going to look at our cos law, and we want to know that part. So let's go A, B, and C. So we're looking for little b, there's little a, there's little c. So b squared, a squared plus c squared minus 2ac cos b. So b squared. A is 4 plus c is 4 minus 2 times a is 4, c is 4, cos 60 degrees. So those two are the same. I should have stopped. B squared and B, AC, AC. There's my first check. Now put my numbers in. It's a little hard to tell because we got a 4 and a 4. There's more 4s over there. B squared, 16 plus 16 minus 2 times 16 is 32. Cos of 60. .5. So B squared, 16 and 16 is 32. Subtract, and then we have 32 times 0.5, which is 16. Squared is equal to 16, so B is equal to 4. Now, staring at this triangle, you may have known that before I did any of that calculation. Because if this is 60 degrees and these two are the same, these are isosceles. It's an equilateral triangle, but you didn't know that. But these two base angles are going to be the same. They're going to be 60. It's all 60. That's because I used 60 in my example. In retrospect, I probably should have used a different number because yours won't work out like this. That yours probably should not come out to be exactly the same length as that. That's why I did the calculation. Okay. But the absolute truth is I built my model and then did all this, and I thought I don't want to rebuild my model. So there you go. Now we know the length of our base. So back to our picture, our model here. That's what we just figured out is the distance here. All right, we know that. Now, to the next page. Next, you will calculate the height of the TP poles. Okay, so we're going to be calculating this part. I'll turn around so you can use that frame triangle. Okay, so this is what we're looking at now. Because sometimes my diagram, this one was the best I could find. It's not that great. Okay, so imagine you're standing in the middle of the teepee where the dark, so this is me, I'm standing right there. How tall is the teepee? Well, we decided that on page 1, and I've forgotten what I wrote. I want the interior height to be 10 feet. So this is going to be 10 feet. So over here, I'm going to label this as 10 feet. How far is it from the center where I'm standing to the edge? Well, if all the way across is 8 feet for mine, right? Because I chose my interior, the diameter to be 8 feet. From the center out, it's going to be 4 feet again. So, model. Sorry about the camera work here, guys. Ladies and gentlemen. All right. So we're imagining I'm standing right there. And based on our model, our interior height we chose was 10 feet. So that's that part. And then the B in the diagram is from the center out. So that's going to be 4 feet again. So that number is going to be exactly the same one. Whoops. This number here is going to be the number that you have over here for number 4. So it's the radius of the circle. All right, so we get a handy dandy right triangle out of that. See, this assignment is really good review. So I'm gonna be honest, my brain can't function. There's too much going on in that picture, so I'm just gonna redraw it. And I know this bottom part is 4 feet, and this part over here is 10 feet. And it's a nice square corner. And this part, the hypotenuse, is going to be the Tipi poles, right? Here we go again. You can imagine, it's kind of hard. It's 3 dimensions. My right triangle, so my square corner is right there. And we've got a side here. And then our other side is up the center here. And then this part forms the hypotenuse. And that's what we're going to calculate now. So hypotenuse, side, and side. Hypotenuse squared is equal to side squared plus squared. If you're doing this along, you should probably just turn off the camera right now and do this on your own. Because, you know, this is boring. You got this. Hypotenuse squared is equal to 4 squared plus 10 squared. Hypotenuse squared is equal to 16 plus 100. Squared is equal to 116. Square root, square root. Hypotenuse is going to be 10.77. So let's go hypotenuse is equal to 10.8. That's going to be feet. All right. So the last part we need to calculate is our frame triangle. We'll go back to the picture, back to the model. So what we're now doing is this part. So if, you know, in Medicine Hat, there's that great big teepee on the Trans-Canada. Imagine you had to make metal plates to go between the teepee poles. That's essentially what we're figuring out here. So we know, what do we know? We know the base, we know these lengths, but I want to know the angles, right? If I'm going to build this out of metal, I need to know the angle up at the top, and I need to know those 2 base angles. So let's take a look, see what we can do. All right, come back down. And I've got it started out for you. So I've even got your triangle drawn. So answer from 5. 5 was on the previous page. Question 5 over here. So my distance across the bottom is 4. And then it says answer from 6C. So this is 10.8. And this is 10.8. And wow, I have got 3 sides of a triangle. So pretty much looks like, you betcha, got to do the coastline. And let's find, what was the rule? I think the rule was try and find the biggest angle first. So just for fun, let's do angle B first. So B squared is equal to A squared plus C squared minus 2AC cos B. So it's going to be B over here, and that's going to be C, and that's going to be A. So B squared, do I know B? Yes, I do. 10.8 is equal to A squared, which is 4 squared. Oops, lost my squared. Plus C squared, which is 10.8. minus 2 times 4 times 10.8 cos B. All right, before I go further, let's just make sure my formula is good. So I got a B at the front, B at the back, an A and a C, and an A and a C. That's cool. Now, when I get this line, I want to make sure I only have one variable left. Everything else should be numbers. There we go. I was looking a little fuzzy. All right, that looks good. So let's do that. 10.8. 116.64 is equal to 16 plus 116.64. All right, 2 times 4 times 10.8 gives me 86.4 cos B. 116.64. All right, 116.4 plus 16 should be like 132. I should have done that in my brain. Minus 86.4 cos B. Now what? I think I need to move this over to here. So minus 132.64 minus 132.64. So 132. Whoops. 132.64 minus, oh, I did that backwards. 116.64 minus 132.64 equals minus 16. Oh yeah, that makes complete sense, right? Because there was the same number there and there. So minus 16 is minus 86.4 cos B. Now divide by minus 86.4 minus 86.4 cos B is equal to 16 by 86.4. Make that negative 0.1851. All right, so angle B it's 79 degrees. Well, it's actually 79.32. So we'll go 79 degrees is equal to angle B. Now, I'm going to give you a bit of a present because we're going to use some prior knowledge and save ourselves some time. Because normally, once you know one angle, you'd have to use, if you start with a cosine law, you'd use the sine law to find the second angle, and then you subtract to find the third. But we can do better. What do you notice about this triangle? What's the word? Isosceles? That's the right answer. If you said the sides are the same length, that's the important part. I mean, isosceles is nice, but truthfully, that's the important part. So we just figured out that angle B down here is 79 degrees. So what do you know? Whoops, that's opposite this one. This is also 10.8. So what do you know about that angle? Exactly, that's going to be 79 degrees too. And if I know two angles, I can always subtract to get the third. So 180 degrees minus 79 again. I have no idea. 180 minus 79 is 22 degrees. So that is my top angle. And I'm going to give you another present for this assignment. Check it out. Do the work, come to me, and I will check all your answers. I've got a handy dandy spreadsheet that I can plug it into. And with a little work between the two of us, you should be able to get full marks on this assignment, or pretty close to full marks. So check it out. Make sure you're not using the same numbers as me. And happy math.